This is video number 1 for section 5.6, creating a single log. This lesson just deals with some more issues regarding logarithms, starting with this first one, creating a single log. When I say a single log, what I mean by that is this. I mean one log with one little base and one result. So log base b of some result, and that's it. And of course, we know the meaning of this. We've been emphasizing that for some time now. Logarithms are just powers. What power? Well, this one would be the power of b that results in x. In this video, we're going to talk about taking more complicated log expressions and changing them to a single log format, something that looks like this. For example, take a look at this first investigation problem. This is close to being a single logarithm. I mean, it looks very similar to this right here. The only thing messing it up is this coefficient, this 4. I'm just looking for some way that I can rewrite this so that I will simply have a log, a little base, and a result. Well, this first one, if you think about stuff we've already done, this is one you should know how to do. We've already had a rule of logs that told us about a number becoming a coefficient. Do you remember where that number came from in that rule? It came from the exponent position. You remember that? We called this the power rule of logs. I'm essentially today just using it backwards. Prior to today, we had powers as part of our result, and we figured out that we could move them to the front as coefficients. Well, today we're just saying if you have the coefficient there and you wanted to, you could just move it back. The power rule of logs. Let's write that down again. I've written it backwards than what we've said before. I think the last time this was all in reverse, but it's the same rule. For this lesson, if I have a coefficient in front of a log and I would like to get rid of it, I can use this rule we're saying and simply put it up in that exponent position. So that's one way we create a single log. One log, one little base, one result. Let's look at the second example. This one very clearly has two logs, and I'm trying to figure out, again, is there some way for me to rewrite this as a single log, just a single log with the same base and one result? Well, I picked this example because we can easily figure this out. Log base 2 of 8 means what power do you put on top of 2 to get 8? Well, that would be 3. 2 to the third is 8. Log base 2 of 4 means what power do you put on top of 2 to get 4? Well, that would be 2. 2 squared is 4. And so therefore, the final answer to this is just 5. Again, I'm trying to figure out, could I get that same answer of 5 by simply having a single log and this one base and this one result? Well, it shouldn't be too difficult to figure out what number goes here. If the base is 2 and the power is 5, I just need to figure out what 2 to the 5th power is. And if you work that out, you will discover that to be 32. Log base 2 of 32 is also equal to 5. Well, take a look at where we started. Take a look at where we ended, and hopefully you can see the pattern here. We're just looking for a pattern so that we can do this quickly. Where do you think that 32 came from when you're looking at the original problem? Hopefully what you notice is that 8 times 4 is equal to 32. And it turns out that this pattern works every single time, and that leads us to what's called the product rule of logs. Let me write that down for you. This is the first time we've ever seen this rule. Log base b of x plus log base b of y equals log base b of x times y. It basically just says if you want to add two logs, notice the bases have to be the same, but if you want to add two logs and create a single log with the same base, you can do that by simply multiplying the two previous results that you had and creating this new result here. And of course, that's why it's called the product rule. The new result is the product of the previous two results. This is not necessarily an intuitive rule. In other words, I don't know that you would guess this. We had to figure it out by looking at this pattern up here. But you do need to learn the rule so that you can use it, and we'll work some examples here in just a sec. Let's go ahead first, though, and go down to this next example, the third and final investigation problem. It's very, very similar to the one that came above. This time I have two logs that are being subtracted, and I would like, again, to see, can I take that subtraction problem of two logs and write it as a single log that has the same answer? Well, these are just the same values we had a second ago. Log base 2 of 8 was 3. Log base 2 of 4 was 2. 3 minus 2 is 1. So I want this final answer to come out to be 1. That means I want this final answer to come out to be 1. Remember, the log answer is the power. 2 is the base. I'm looking for the result. I just need to figure out what 2 to the first power is. And of course, that's an easier one. That's just 2. Now we look for a pattern. We're trying to figure out, how could I just start with this and end with this quickly without doing a whole lot of work? In other words, where does this result of 2 come from? Why did that work out? The last time we had a product, right? We had 8 times 4 that made 32. Hopefully what you can see this time is that we have a quotient. Instead of these two numbers being multiplied, they're divided. 8 divided by 4 equals 2. Well, that leads us to what we call the quotient rule of logs. And let me again write that down for you. Log base b of x minus log base b of y equals log base b of x divided by y, right? That 2 was 8 divided by 4. It always works. If you want to subtract two logs and end up with a single log, all with the same base, you can do that by simply dividing the two previous results. Notice it has to be the first one divided by the second one in that order. These are complicated rules, and you do need to learn and memorize them. One thing that might be helpful in learning them is to think about the connection with the rules of exponents. In fact, that's really where these rules come from. Remember, we had that rule of exponents that said if you want to multiply two guys with the same base, you add the powers. And then we had that other one that said if you divide two guys with the same base, you subtract the powers. So there's that connection between multiply and add and divide and subtract that we've already seen, and that might help you to remember these things. Okay, taken together, the power rule, the product rule, and the quotient rule are often referred to as the 3 famous rules of logs. Now that we have them, let's try to use them in a couple of example problems. So the goal in these problems is very simple. It says we just want to write this complicated log expression as a single log. Just one log, one little base, and one result. Well, when I glance at this first example, of course, one of the first things that pops out at me is, oh, I have 2 logs here. There's a plus sign in the middle. That kind of reminds me of that product rule of logs. But if you look closely at this, you will see this is not quite an exact match. You can only use this rule if you already have 2 single logs there being added. In other words, there's no coefficient sitting here for the product rule of logs. You'll never be able to use this until you get rid of any coefficients that you have. And I'm looking in my example, I've got this coefficient of 4. How am I going to deal with that? Well, I'm sure you already know. We dealt with that first, right? If I have a coefficient I don't want, I simply use the power rule to move it back up to the top there of the previous result. Let's use that to write down what we have. So I've used our power rule of logs to move that 4 back up into that exponent position. I didn't do anything with the second one. It was fine. It didn't have any coefficients. Once you've dealt with the coefficients, now you do have an exact match to that power rule of logs. And I have the left side of that rule now. I'm going to change this into the right side. How do I do that? Well, the rule says if you have two logs with the same base, you can rewrite it as a single log. How do you do that? By multiplying the previous two results together. I had x to the fourth, I have 3x squared. If I can multiply those two pieces together, that will be my new result. Well, let's do that. Let's see, really I've just got another dot right there. We always put the coefficient at the front, so that would be the 3 at the front. And then rules of exponents, x to the fourth times x squared. That's that situation where the base stays the same and we add the powers. Here is the final answer to this problem. All we were asked to do was create a single logarithm. And we did. One log, one little base, one result. Let's try the second example. A similar situation here. Of course, the first thing that pops out at me is I've got a couple of logs being subtracted, and that reminds me of that quotient rule, but I will not be able to use that rule as long as there are coefficients. You can glance at it, and again, notice to use the quotient rule, you have to already start with two single logs being subtracted. So I'm going to have to go ahead and deal with that part first, using, once again, my power rule. So this 3 coefficient will come up as an exponent. This 2 coefficient will come up as an exponent there. Let's write down what we have. Pay attention to how this is written. This is a little trickier than the last one. When you move those coefficients up, it becomes a power of the entire result that was there before. So that entire x squared is now being cubed. Similarly, for the second one, the entire 3x is now being squared. Let's go ahead and clean that up. For this first one, it's another rule of exponents, one base and two powers. That's the one where you keep the base the same and multiply the powers. For the second one, I'll have to use that rule that says I can distribute that 2 into both parts of this since it is a multiplication problem. That would give me 3 squared, which is 9, and then x to the 2 is x squared. That's the result of me using the power rule of logs. Now I have two simple logs being subtracted, and I can go ahead and use the quotient rule. It's an exact match for the left side of the quotient rule. I'm just changing it to the right side. Well, according to the rule says you can take a subtraction problem of two logs and change it to a single log by creating the division problem of the first item divided by the second one. It has to be in that order. The first one on the top and the second result on the bottom. All that's left for me to do now is to simplify, to clean this up. There's not a whole lot that I can do. I can't really do anything with the 9, but I do see that x to the 6th over x squared, that's one of those rules of exponents, right? It's the one where the base ends up on the top, and I subtract the powers. 6 take away 2. Again, the 9 is going to be left where it is. Here is the final answer to the problem. Again, I created a single log, one base, one result. In our next video, we'll talk about why creating single logs is so important.